So thank you very much for being so patient and waiting with me to figure it out. And thanks everybody that came by to help and all the cables I now have around me. I think I'm pretty fault tolerant at this point. And hopefully my demo will also give another example of that. So today I would like to give you guys a talk about my journey on discovering a bit about Kafka. So configuring Kafka producers for stream processing. And it's by me, Nsemeke Ukpong. So I'm an IT engineer at the One Analytics department at ING. I'm born in England, born in Nigeria, Nigerian born, and lived in England for a while. I've now been in the Netherlands for the last 11 years. My academic background is intelligent systems and product development, and I've been working at ING for just under 5 years. Before ING, I was working for IT projects in the energy sector, technology incubation companies, IT consultancy, and design research sector. My personal ethos, although this varies depending on the situation, is that good results can be achieved alone, but for great results, collaboration is key. And it's really from that perspective that I'm here today, because I want to hopefully share with you guys what my experience has been to inspire other people to jump on board on the big data bandwagon so that we can all collaborate on experiencing these technologies and making them mature. So during today's presentation, I'm going to go through a few topics. First will be strategy. Why is ING in the big data space? Why are we using a data-driven strategy? Next, I'll talk about some implementations that we have where we've actually realized some data-driven applications. I'll show the use cases from a user experience standpoint and also the application design and architecture behind them. After that, I will talk about Apache Kafka, which is the cornerstone of these architectures, and how it plays a role in the streaming data pipelines. Finally, I'll demonstrate some of the features of Kafka producers and how this supports fault tolerance, which makes Kafka such a popular tool today. Okay. So, strategy. Why is ING in the data-driven space? So ING is a top financial enterprise operating since 1881. And I didn't make that up. We've recently won the Global Bank Award in this year and actually last year as well. We are a pretty big organization operating worldwide. We are in 41 countries, employing 52,000 employees, and we have 33 million customers. So we didn't get to that point just by chance. We got there because we continue to monitor changing trends and to make sure we stay on top of it and we continue to evolve and adapt ourselves. What we notice is that customer behavior is changing. Customers are having less and less time. They don't want to be spending time in finance. They just want to take care of the financial experiences. The landscape is becoming competitive. Products are becoming commoditized. The only way to distinguish ourselves is through customer experience. Technology is rapidly changing. There are more and more fintechs coming into the market, which is challenging us to keep up up the pace and to see how we can make sure that we continue to maintain relevance in the financial markets. Society is changing. With technology expansion, borders are disappearing. And finally, the regulatory market remains pretty uncertain. We are constantly having a push and pull dynamic to figure out how can we operate whilst serving the customers, but not abusing the rights that we have as a financial entity. So the challenge becomes, how do we make sure we know our customers well? In the past, finance used to be about a building, a place that you go to in town to take care of your financial situation. Nowadays, however, everything takes place online and on a mobile phone, which means you can do your finance anytime, anywhere. This places big demands on real-time availability and high availability. So we have to make sure that we know our customers' needs and anticipate it. So the question becomes, do people still need banks or just banking services? We're looking at the top service providers online and seeing what they're doing well. And we've noticed that they're distinguishing themselves not by physical capital, but by digital capital, how much they know about their customers and how they can make sure that their customers' needs are met or anticipated upon. Whoever controls the customer experience controls the customer value. So this is a critical part of our Think Forward strategy. The Think Forward strategy aims to empower people to stay a step ahead in life and in business. There are four core components of this. These are that we aim to provide customers with services that are clear and easy, that are available anytime, anywhere. We aim to empower the customer with these services, and we aim to continue getting better so they know that we're still the preferred financial service provider for them. From an organizational standpoint, this requires quite a few changes. Well, not big changes, some things we're already doing pretty well, but certainly focal points. We are looking to simplify and streamline. We're looking for operational excellence, and we are really driving a performance culture. And we're also lending capabilities across departments, across countries. We've already made big strides in this. We have two key departments within the organization, Customer Analytics Department, called it KIM, Klant Informatie Management, and one analytics department, responsible for then transferring the customer information into actionable insights for the customer. We've also appointed a chief data officer globally to make sure that we are looking on a global scale, from a global perspective, at how we are managing data and data governance. The good thing is, as a bank, we have lots of data. As you'd say in Dutch, we zijn data zat. So this pyramid gives a brief overview of some of the information that we have available to us, with the core data being at the very top. So party data, product data, agreement data. This is just a tip of the iceberg. You can imagine that with our mortgages products, we get to have data about the customer, reflecting a relationship with the customer of 30-year-long lifespan. But next to that, we also have real-time data concerning operations, transactions, system, processing. We also have information about risk, from HR and from finance. All of this is there at the fingertips, ready to be organized, harnessed, with the right architecture, with the right use cases. So we've already made some steps in this area. So I'm going to now tell a bit about some of the implementations we've used to harness this data. One of the applications we have, or capabilities rather, is called Kijk vooruit. It's already available to a small customer base. And it's there to, on the mobile, allow the customer to look ahead at the financial situation based on the financial history. Let it play a little bit one more time. So if you're already banking with ING, you might be in the customer base that has access to this. Okay. All right. Next. So the flow is as follows. The main API is a forecasting API. Here we are using Aker actors to make sure we are implementing the computation algorithms in a scalable manner. We interface with our backend services to get information about direct debits, salaries, standing orders, to be able to get information about existing transactions that are happening. And then within the forecasting API, we make computations to figure out what predictions we can make for the customer about what the future financial situation would be. This information is then exposed through a Spray HTTP endpoint and to the mobile API, which supports both Android and Apple mobile phones. Another application that we have is related to customer interactions. So we have several campaigns running out throughout the year, and we have employees who are busy with these campaigns. Typically, they would put their campaign information in the campaign server. This campaign information is something, so for example, not customers necessarily, but customers perhaps, contacts that they're having for this campaign, and actual communications that they've had with these individuals for the specific campaign. This is then stored in the campaign server. This information is synchronized with other data stores, Oracle and Netezza, and we have Spark jobs which pick up this information, processes them, and collects them and presents them again to different communication channels. The point of this application in its entirety is to help us make sure that we do not contact the customer too often, but also not too few times. So we want to avoid spamming the customer, in short. And with these communication channels, we are able to make sure that with each channel, we're using the right amount of interval, let's say. So with email, you can imagine that it would take 3 emails before you might feel like it being spammed. And with our databases, we can calculate and keep track of how many contacts the customers had per channel and make sure that we don't contact them too often. So we might decide, okay, a customer has been contacted last week, so we have to wait another 2 weeks before reaching out to them again via email. But maybe with telephone, it's actually easier. And in this way, we are tailoring our communication to the customer's needs so that they can have a good experience with us. So those were existing applications which are currently operational, but we are moving towards the target architecture. This architecture, it's called our Touchpoint Architecture. If you're familiar with WeChat, it's something in that vein where we are aiming to provide a platform on which all application or all customer interactions will sit upon. All interactions will be touching this architecture. The technologies powering this architecture are Flink, SAS, Kafka, to name a few. Below you can see the servers that we expect to have. These could be Cassandra, Hadoop. We're still seeing what's possible. The overall aim here is to provide a standardized and centralized manner for handling customer events, customer interactions, and to make sure that we are generating insights from this that are tailored to the customer's needs, that are happening real time, and are customer aware and using the right communication channels. So you can see that we are supporting letters, web pushes, email, SMS, online ads, inbound REST APIs, etc. And all of this is, again, real time and using machine learning algorithms to make sure that we are carrying out relevant computations to make so the customer interaction is useful for the customer. An example of a use case that would operate on this platform is shopping situation. So a customer is out shopping, and with our platform, we are able to register every payment as a transaction event. And using our customer information, we can we have an algorithm to detect whether or not this person is shopping. So we have a shopping pattern detection algorithm. Now, with our information about the customer, such as balance information, but it could be something else, in this scenario, it is going to be balance, we will detect that the customer's balance is actually going too low, meaning that the next transaction, they probably will not be able to afford it. So we will send a notification to the customer's mobile phone, telling them, hey, your balance is falling below a certain amount, and you probably want to have more money because you're in a shopping situation. Would you like to now make a transfer from your savings account to your payments account? This will allow the customer to have a seamless shopping experience, not having to be embarrassed at the point of sale situation, and actually, in advance, have the money they need to continue shopping experience. So in these architectures that I've shown before, there are quite a number of technologies being used. And in this overview, you can see a number of them: Hadoop, Oracle, Spark, Scala, Flink, Akka, Cassandra, to name a few. And this doesn't cover everything, to be honest. I will move on to talk about one of the key technologies. In the last architecture, the Touchpoint Architecture that I mentioned, Kafka was, as you can see, the really central point here. The decoupling between the event sources and the event processors. Before I deep dive into Kafka itself, I want to tell a bit about streaming data pipelines. So within the streaming data pipeline, you have certain concepts that are worthwhile knowing. This is the concept of the sink and the source. In a pipeline, you have a data producer, which writes with a sink function, and you have a data consumer, which consumes or reads with a source function. It thus follows that the thing that is written to is seen as a sink, and the thing that's consumed from is seen as a source. With a message broker architecture here, as depicted in this diagram, the broker is then the source and the sink. And the data which is written is seen as the source for the consumer. So Apache Kafka, I think, has come up quite a few times in this conference. It's a very popular broker, message broker. It's a cross-platform stream processor, and it's a glue of any streaming data architecture. It was originally developed by LinkedIn and then open sourced in 2011. Its primary contributors are employed by Confluent, who also provide the enterprise commercial support. It is distinguished by its ability to deliver massive streams of messages in a real-time and fault-tolerant fashion. It's also used by large and small-scale enterprises alike, including LinkedIn, Twitter, Netflix, Spotify, Uber, to name a few, and many, many more. So it's a proven technology, and it's been existing for a fair amount of time. And I also learned at the previous talk that they've released now a version 1.0 since today, in fact. So it's getting to a very ripe maturity level. So what does a Kafka architecture look like? A typical installation would consist of a zookeeper instance, but the core part is actually the brokers. And within a broker setup, you would have, within a cluster is made up of one or more brokers. So here you see the primary broker, and you see 3 others. Let me see. I'm going to get the pointer, because now you can, which do not have to be there, but for fault tolerance reason, it's ideal. Otherwise, you don't really have much of a cluster going on. Next to that, to make the pipeline work, as I mentioned before, you have your producers and you have your consumers. Again, in the architecture, you typically have consumers grouped according to consumer groups. And within each group, you can have one or more consumer. The zookeeper instance typically knows most information about the cluster. And so you see here all the errors from all entities going to the zookeeper. Now, going deeper into the broker itself, a broker is broken down into partitions. A partition represents a topic, and client producers write to a single partition from a topic. And that is the lead partition. Each partition is replicated amongst different brokers for fault tolerance. So here you have replication of partition 0 across broker 1 and broker 2. However, the only broker capable of read and writes from the consumer and producer is actually here, the red one, the lead partition. And you see here that each broker has multiple partitions. A topic itself can be broken down to multiple partitions. That is then more for load balancing purposes. And the fault tolerance we'll be exploring that later on. So, I mentioned a bit about topics. Topics are actually a very critical factor. As a producer, you are, in essence, from an organizational standpoint, the owner of a topic. It's part of what you're delivering to the stack, to the consumers. There are a number of producer configurations. I haven't listed them all here. For sure, there are not just 3. But some really important ones that I find relevant if you're getting started with this kind of architecture, I've listed. That's bootstrap servers, retry mechanisms, retries, and acknowledgements. So bootstrap is there for your initial connection. If there isn't a bootstrap server alive, then your producer will not be able to discover what the cluster consists of. The retries are there to make sure that if something goes wrong, without any intervention, your system continues to attempt to make a connection. And finally, you have your acknowledgements. This is there for message durability and guarantees. This can have influence over your throughput, latency, and durability. And I won't go into the details here at the moment, but it can have 3 different values. 0, 1, I see -1, but it's actually, there's an all is one of them. Okay. So, now the demo that you were waiting for. Okay. So before I switch to the demo, let me tell you a bit about the stack I'm using. I have 3 brokers up and running. And of course, there's one primary broker, which is more one broker having the lead partition. I also have one Java Flink program running as a producer. And I also have one Kafka console consumer. I created a topic using this command here. And the topic here, as you can see, has a replication factor of 3. That means that its partitions are being replicated 3 times across the 3 brokers. So each broker has 1 partition. So, and now let's make a semi-smooth transition to the other screen. Oh, that actually worked. So, all right. First, let's look at the code necessary to create a Kafka producer. So, I've used an example actually from Data Artisans. It's pretty lightweight and does just enough to get you acquainted what you need to get acquainted with. It provides, it's as I said, it's a Flink example, which has makes use of Kafka connectors. And what's really relevant to see is here, the add sync that I mentioned earlier. So it uses the add sync function to generate a data source. The data itself is a message stream of this nature. And it's just a simple string in this situation. To give your configs, typically you would give it as a command line arguments. However, for the simplicity of demoing, I've put them here as programmatic static values. And here you see the Bootstrap servers that I mentioned earlier. And of course, your topic, which is a critical component of your producer. What is worth noticing is that here I've put down multiple Bootstrap servers. This is again a fault tolerance component. If you want to test fault tolerance and there's only one discovery server, let's say, then once that one's down, nothing else can work. What's also worth noticing, so I've also mentioned, added this parameter of parallelism for the environment. This is not in the code originally. This is more that Flink typically runs with a parallelism of 4 by default. And for the simplicity of demoing, I've set this to 1 so that we're not having excess events or activities going on. Okay, I think that covers the main points. So we can go now to running things. All right. So I'm going to start up the program. And I will start my brokers, which actually the program will fail because right now there are no brokers up and running. So let's start that now. Nope, Zookeeper is not running, so that has to be first. Oh, okay. Just a second. That doesn't look like a successful startup, but let's check if it's working anyway. I'm not optimistic at this point, but I'm going to risk it. Let's see. Aha, it failed. Okay, so it seems that during the restart of my laptop, some things got reset. So if you give me a minute, I will kill some processes and get this up and running. Let me just see. Okay, strange. Should be working. Let's see. Try again. No, it's not. I just saw the detail. It contains some of the wrong information in there. So it's actually this one. Okay, that looks much better. Yeah. And now the third broker. No, that should actually be fine as is. Okay, and now if we restart the application, it's able to publish messages. So here we see that the application is writing to Kafka. It's writing to a leader of, which is on broker 2 here. If I pause it. And it's written now up to 9 messages. It's now on message 9. So I'm going to demonstrate the fault tolerance, as I've mentioned, by killing one of the brokers and showing that without any intervention from me, the application manages to recover and continues to write and returns to business as usual. So let's keep this running. And let's kill one of the brokers. And I'm going to kill broker number leader. Yeah, broker 2, which is a leader. Awesome. Let's try another way. All right. That wasn't supposed to happen. So it's completely crashed my program. Because, of course, I've killed 949, which is killing way too many processes than needed. Including here, you see 953, which was probably the operation for the bootstrap itself. So we'll try again. Restart the writer. And let's try which leader. It's still leader 2 again. Okay. Why is my control function not working? It's strange. All right. I'll try picking a different process this time. Process ID this time. So I have 1 of 3 chances of getting this right, guys. So let's see. Okay, I think I did it. No, it's exited. Oh, I've killed the connection to write Kafka. Okay, so 1 of 3. This next one should be getting there. Let's restart. Or maybe I should actually stop this, then it doesn't connect. Then I have 1 of 2 chances of choosing the right process ID. And this one is stopped. No, it's still running. Still leave the partition 2. It's really fond of broker 2, apparently. Normally it's a bit more random. So let's try Well, let's just do it this way, actually. No, no, of course not. Doesn't work. That was foolish. Yeah, it's still running in the background. Oh, no. Yeah. We'll start up again somewhere else. Or really determined to fail. But yeah. Let's see. Okay, so I'm going to start up broker 2 again, because I need it for my topic. If I try to run this application without all brokers being up and running, then it will complain. Oh wait, maybe it wouldn't. Let's see. Yep. Complaints. Let's see. So broker 2 is back up and running. And this should now run. Okay, it's back to producing messages. And let's try once more to... It's leader 2, yeah. Okay, I'm going to double check. What is a command for killing a process on command line? Because Control C. Yeah, I've tried that already. Ah, there it goes. Yeah. Yeah, let's see. No, they are, well, actually, well, let's see. Let's see. Describe topic. So, yes. Okay, then I'm going to recreate the topic because somehow that's been reset.
Only one partition, one replica, that's bad.
Indeed. The joys of having a laptop having to be restarted at the last minute. Okay, so I'm going to recreate the topic again because apparently that's been reset. Let's see. Create topic. Partitions 1, replication factor 2. So broker 1 is up and running, broker 2, let's start this one. Oh, okay. Yeah, I have to change the topic name. Okay, so we're back to up and running. And the leader is 0. So now if I kill this one, we should see that the leader transitions to 2. Ta-da! So that is the fault tolerance. Zero intervention, all I did was kill one of the brokers, and it continued. And actually much quicker than I've experienced before. Normally it takes a few more seconds than that. So actually that's what you didn't get a chance to see because it was so quick, is that normally it does a number of retries by itself. And if it takes a long time for the broker to get up and running, then you really have I don't know, 3 or 4 or 5 retries. But that is the demonstration that I have to show.
What sort of guarantees would you have now about messages being published? Could there be like a duplicate publish, or do you know that it happens exactly?
So with this one, there are no, there's very little chance of duplicate publishings taking place because the producer is only, a consumer is only able to receive a message once it's been committed. So with acknowledgement mode, which here by default is 1, it's the persistence level is at lead level. That means the producer has to first get acknowledgement from the lead broker before it says, I've succeeded with publishing this message. Okay. Other questions? All right. Well, I am ahead of schedule a little bit, so I had some more slides I would like to show. Okay. Let's get to full screen. Wachten op Google Docs. Let's try a different approach. Yeah, okay. So, if you want to try this yourself, it's actually pretty simple. As I said, I used the example project from Data Artisans, and I made some modifications to it. It's also good, of course, to read the intro. Provide the link there. Some tips, as I mentioned, use multiple ports. This is not in the initial example. I've set up my configuration programmatically instead of viewed through the command line, just so it's easier to fiddle around with. And I said, yeah, use different port numbers. I mentioned Bootstrap servers. Different port numbers. What I noticed for myself is that as I try to kill the different brokers, different processes were still using them. And if you change the port numbers, you can find something a bit more unique. Makes it a bit less headache. I wouldn't recommend doing that necessarily in a production situation because maybe those processes are necessary, but for strictly this situation of playing around, it's okay. For me, what I found interesting as I was looking through the documentation is the fact that the setup I'm using from Data Artisans is actually using Kafka version 0.8. And as I mentioned at the beginning of this presentation, they've released the 0.1.0. Amongst all the other features, which I haven't read all of, but one of the key features from that is that it now offers at least, exactly once guarantee, which is pretty cool. Now, what would be nice to experiment with is how to upgrade the Kafka server and client to this version in a smooth and painless and seamless way. So that will be one of the next challenges I'll be looking into. Let's see. I will not. So I also have some links because many of this information I didn't make up myself. I didn't create everything myself. So here are some good references if you want to read up some more about all the information I've shown today. And if you want to know more about what ING is doing in this space, we have lots of information available online from Facebook to YouTube to LinkedIn, SlideShare, and Flickr. So please follow us to stay a step ahead. And we are hiring. So, thank you.